Good evening, everyone. I am your host and instructor, Laney Shaughnessy, and welcome to Spindle TV, your best source for CNC CAD/CAM training videos. Spindle TV is brought to you by Digital Woodcarver, inspiring your creativity and providing you with the tools to create your own unique masterpieces. Good evening, everyone. Oh my goodness, how are you guys and girls doing tonight? Hopefully everything is well. Hopefully the audio is good. And we are geared up to finish off this fourth axis training. Dum, bum, bum, bum. All right, we got a few more people to come on in. Welcome, Steven. Steven. See, you were gone just for a moment and already forgot how to say your name again. Hey, Steven, how you doing, buddy? Glad to see you in class tonight. Hopefully you guys and girls got the step calculator program that I posted in Facebook. Give it a shot, give it a whirl. And as far as the fourth axis setting files, you will have them tomorrow evening. You will have them in the Facebook group. The fourth axis setting file for TNG, you will have them tomorrow. Burl and I together will be creating them while we're in Milwaukee tomorrow morning. We're going to be testing the fourth axis with the new setting files, make sure everything is good to go, and then I will post it in the Facebook group tomorrow evening, and you'll have it. Yay, finally. All right. All right. Well, I'm glad you're comparing me to Bob, old Bob Vila there. All right, I had to get something to drink. Yummy, yummy. So, hopefully everybody's had a good day today, and I'm looking forward to giving this project a shot. See how we do. Let's see how we do. I'm pulling over my files and everything. Let me grab this one as well. There we go. I'm gonna let everybody, gonna give it a second, just let everybody get a chance to get in and get set up. All right, let's see here. Question on the step calculator. Since I use a Gecko Drive, I should be pre-2016 settings, correct? Your fourth axis and everything would be pre-2016, Stephen. I believe. And one way to test that out is do a step calculation with the pre-2016. Take on your, let's say it was a 2-inch diameter or something. Take a small blank or something, and or even just on the head of your router, like on your chuck or something, and make a mark and have it run that step. Like G0, Y, let's say it was 795, whatever your step is, that step calculator created, and hit enter and see if it will rotate. If it rotates a full 360 degrees, then that is the correct option for you. You are either going to be the pre-2016 or the 2016, but I think you are the pre-2016 setting. I believe you are the pre-2016 setting. Alrighty. So we got a few people popping in still. Welcome Wayne, welcome Peter, Alan. Snow tomorrow night, no work for tonight. There you go, Alan. That's good. All right, let's get this fold back into full view here. All right. Good, Jerry. Good. Hey, Jerry, thanks for sending me that photo of that keystone. It looked like it came out well. I'm glad to see that, that keystone project. Again, let me know if you need anything, and I can make any adjustments necessary. All right, ladies and gentlemen, we're going to kind of jump right in. We're already at 7:23, so let's go ahead and transition over to the Vectric software. We are continuing on, and what we're going to be working on tonight is we're going to be working with a federal table leg. And Wayne, the cost for the fourth axis, I'm not sure what the Canadian dollar conversion is and everything, but it's $795 US. So I'm not sure what the Canadian conversion is if you buy through Stockroom Supply, or if you buy directly through us. I'm not sure, but if you buy US, it's $795. All right, welcome, Michael. Good to see everyone. Okay, so we are going to switch over. Let me switch over to our other screen here. All right. And we should see here in just a moment, we should see the federal table leg that we were working on the other night. Okay. And what we're going to be talking about tonight is when we're working with a project that has, the top of this leg has a square post. This is where our apron and things would go. If we were carving this leg out of a round post after our rounding toolpath and everything, to true up our stock, how do we get back to that square? At the top, if everything kind of wraps and goes around. And so what we're going to do is we're going to I kind of started over with this kind of from the beginning, so that, because in last Monday's class we had talked about the 2-rail sweep. We talked about different things on, wrapping projects around, 2D vectors and stuff and designs. But I want to kind of focus on the actual, like if we were doing a spindle or a table leg, in this case a table leg, we're making a farm table or something, how we would make this leg from start to finish if we were designing it out. Now, the one thing that you can always keep in mind is, we can use specialty router bits to help optimize our toolpath. What the method that we use when we're fourth axis, when we're doing a model carving, we are usually using a ball nose end mill, 1/8 inch ball nose, 1/4 inch ball nose, whatever it may be. And this ball nose end mill is milling out this part. And so it's a long process. It's a long run. Well, we can optimize a lot of our profiles by using specialty bits, router bits. And I want to kind of touch on that a little bit tonight. We're going to touch on that here in just a little bit to kind of see how we can create a profile if we had that specialty router bit, that OG bit or that foreign bit or box core bit or something that had that shape of that profile to help us kind of create our designs and our spindles. I want to touch base on that and everything, so hopefully you'll look forward to that. And then I'm going to provide everybody with this magnate file that I'm going to be using when we do talk about that. But let's go ahead and get this laid out. So right now we are going to start from the beginning. We're going to hit cancel because we have to do a wrap job setup in order for this effect, this method to work to get this square blank. So let's start from scratch here and let's go, let's close this out. And we're going to go into gadgets. We're going to go in the gadgets library and we're going to go down to wrapping and we're going to do a wrap job setup. Okay. Now for this wrap job setup, our table leg, our length of our spindle is going to be 32 inches in length. And the diameter of the cylinder, this, if I'm not mistaken, is going to be a 3.5 by 3.5 table leg. So we're going to go 3.5 on that. We are going to be wrapping the Y values around the X-axis, so that default setting that's there for us, we want to stick with that. Our XY drawing origin, where we're going to be starting from on our drawing, is the bottom left corner. And for our Z origin we're going to be working or zeroing out our Z from the center of our cylinder, which is in reference to the bottom of our material when we unwrap it. You know, in the top or the bottom, it's the bottom, because that represents the center of our cylinder when it's wrapped. Now, I'm going to show a little clip, if I can find it quickly enough, of an unwrapping of a cylinder, so you guys can, girls can kind of get it when you say when we say unwrapping and stuff. What you mean. And we're going to do a simple cylindrical wrap, but what this does for us when we set up that job, in the job setup, it puts in our length and then it gives us the circumference of our 3.5 inch by 3.5 inch cylinder if it was unwrapped. Well, what does that term unwrapping mean? You know, unwrap, you know, because we're working in a flat plane, and let's see if we can kind of illustrate this quickly enough. Now, this was something that just popped in my head because I do have this little graphic that I made, but I wasn't prepared ahead of time, so bear with me for just a few seconds while I find this file. And it would be in Documents, Digital Woodcarver Cells. Unwrapping a cylinder. Let me see if I see A, B, C, D, E, F, E, U, H, I. Where's my folder that says class, show class? There we go. This is what I'm looking for. Alright, so inside this folder is a neat little graphic of unwrapping a cylinder. Stick with me, kiddos, and we'll find it here in a moment. I know it's here. I know it's here. Let's go into a lot of files go into creating these little videos and clips. Alright, opening, class, closing. Oh my goodness, hold on a minute. Let's go into my flash drive, M file. And let's see if we've got unwrapping a cylinder down here. It's a video file, so it shouldn't be hard for me to find. All I got to do is find it. You guys talk amongst yourselves for a minute. This was something that popped up in my head, but since I threw it out there, we'll find it real quick here. Let's go into, I've got millions and millions of files. So let's go into our backup folders here. And we've got our 4th axis touch plate, CNC files. Oh my goodness. Go down to the U's, because you're looking at all these millions of files. These are lessons after lessons after lessons of different things. These files are created. This is one of these days. I've got a young lady who's going to go through and remove any unnecessary stuff. All right, STUVW. Up, 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 up. Hey, there's my dice files. Wonder where those went to. Alright, stand by. Let me stick my other flash drive in here. I think it's going to be, I do apologize. I thought everything was going to be smooth tonight. Let's go into that. I just inserted my flash drive. There we go. Alright. Okay, if we do not find it here in the next minute or so, we are moving on. All right, we will come back to that. Let me continue searching in the back end. We don't need to be kind of getting stuck on that. Basically, it was a very short video clip showing a round cylinder being unwrapped and giving the definition of the circumference. And you guys and girls are all adults. You've all taken math in school. You know that to find the circumference of a cylinder, you take the diameter and multiply it by pi, 3.14, and then a million other numbers after that, but 3.14 basic. And it was just a simple illustration, so I shouldn't even wasted that much time on finding it, but I will find it before we leave, and we'll kind of just see that. Oh, hey, by the way, here's how to unwrap a cylinder. I wasn't prepared. That was not something that was going to be in tonight's class. I just thought, hey, let's give it a shot. No, we're not. Yeah, it's shot time, right, Baron? It's there's 100 of them going on. All right, so we've got our job set up here, and let's go in now, and we've got our wrap job. This is a wrapped output. You want to see this wrapped output, out here, letting you know that you created this file using the wrap gadget. What that does for us is when we do the method that we're doing, now within our gadgets and our wrapping tools, we have what's called the vector unwrapper. Let's get, my mouse is going a little bit berserk. Let's get back over there. We have the vector unwrapper tool, and I'm going to be teaching you how to use that vector unwrapper so we can demonstrate how to create this square part. So let's bring our federal table leg back in here, and let's get it centered up on our project board there. Okay, and now I don't need it on my project board. I need to bring it down. I'm just going to kind of drag it down down underneath here, somewhere in that general vicinity, not facility. But we have a very round tapered leg here and everything, but we have this square part where our apron and everything is going to go on our table. We need to create that. But all of this internal, these internal dimensions and things or vectors, not dimensions, sorry, these internal vectors that here, these are just for show. This is just to kind of give this 2D vector a little bit of, so you can kind of see what the leg is. But we do not need that. So we're going to go ahead and delete those inner vectors. All we need is half of this outside profile. So we're going to go and we're going to select on this profile, and we're going to come into the node editing, and right on this span, a span is a line between two nodes. Right on this span there's a center point, and I'm going to snap to that center point, and I'm going to right click and cut the vector there. On the other end, on this span here, there is a center point. I'm going to right click and I'm going to cut the vector there. And that way I can come into my normal selection mode and I can remove this lower half. All we need is this top half for our part, you know, from the center of the cylinder out. Now we are going to be doing what's called a 2-rail sweep, and when we create this 2-rail sweep, we are going to be basically, to do a 2-rail sweep, we're going to do the line tool, our polyline tool, and oh, black screen, black screen, black screen, black screen. I don't know why it does that to me. All right, I got you. Hold on, black screen. Okay, thank you for that text alert and everything that made me look over at my screen. Give it a second, it'll pop back in. All right, let's back up. Let's back up, Jack. Let's back up, and we'll start over just like you didn't miss anything. We're going to import that federal table leg, and we're going to import that federal table leg, and we're going to open up our alignment tool, and we're going to center it on our material. Now, I do not need it on the center of the table, so I'm going to go ahead and just kind of drag it down here underneath. Now, what I was saying before we went to black screen and everything is on this table leg, all of these inside vectors here, we do not need. We are just, they're here for decoration, just to kind of give this two-dimensional part a little bit of, you know, so we can kind of get a visual of what this leg would look like and everything. So we're going to go ahead and delete everything except for that outside, oops, that outside vector there. So we're going to go ahead and delete all that out. And we're going to go into node editing mode, and on this outside vector here, we need the top half of this profile. We don't need the bottom half. So on this line here, a line between two nodes is a span. We're going to go ahead and we're going to right click on this center point of that span, and we're going to cut the vector there. And then over here as well, on the center point of this span, we're going to snap to it and we're going to cut the vector there. This way we can go back into our normal selection mode and we can remove that lower half. We don't need it. Alright, so as I was saying before you guys, so since I put the USB in, okay, then it found, I did get a special ringtone, Baron. The phone went off and the alarm made me look over at the screen. But I couldn't find that file. And so when I put that USB in, I couldn't find that file. And we were basically, I was, that whole time I was searching for that file to show how a cylinder unwrapped. We could not find it. I will show it later. But basically, to find the circumference of a diameter, we multiply it by pi. The wrapped output, that wrap gadget that we use, automatically does that for us when it sets up our job. It takes our 3.5-inch diameter and multiplies it by pi to give us our circumference in that y-axis. Okay, so we now have a another tone coming across. Let me see if I got what we got going on here. All right. Are we back on track now? Everybody's got sight, sound, and scenery. All right. So the wrap gadget, that wrap job setup, has done that for us. All right. So now we're going to be doing a 2-rail sweep. So we are working in Aspire, guys and girls, for this project. This is an Aspire function and an Aspire feature. So for you all that have Pro and Desktop, do not be discouraged or run away or leave or anything. You know, stick by, because learning how to do this stuff is important, because one day, whether it's a model that you're creating if you ever get Aspire, or it's a model that has been created for you and you're bringing that model in to your Vectric VCarve Desktop or VCarve Pro, you need to know how to work with working with these tools and these models, these components. And so it's a good lesson. It's a good lesson learned. I mean, there's no harm in understanding the process. So the what we need to do is, with our 2-rail sweep, we need drive rails. And what I'm going to do is, I'm going to, on my legs of my table, I'm going to open up my draw polyline tool, my polyline tool, and I'm just going to hover my mouse over the corner of this vector to wake up that point. Now when I bring it up, you'll see that line come in, and now I can snap to that horizontal. You'll see that horizontal line pop up as well, that intersection. So now I can left click, and that creates that start point, and I can come in and I can continue straight up and get to my horizontal line here as well, and snap to that point. And then spacebar to finish off the tool, but stay within the create polyline tool, keeping it open. Now over here as well, at the end, we're going to snap and wake up this corner. So we're going to get our polyline tool, snap to that, and finish that off. That's going to be our 2 drive rails. Now I'm going to go ahead, and at this point, this is a good lesson to talk and teach to you about 2-rail sweeps, or not 2-rail sweeps, sorry, but layers and stuff. Now I have a layer here called the 2-rail sweep rails, and that layer is basically going to be the layer that my drive rails here are going to be created on. Now, even though my board, my my stock is 32 inches, my actual part of my table leg should be right about 29. That's the length of the table leg, and that's exactly what I want. Okay, and so that's my 29 inches. Now this excess stock here is going to be, what's going to be my waist area and all. So I'm creating my drive rails. Now I'm going to go into, and I'm going to turn on this drive rail layer, and I'm going to delete the 2 drive rails that are in this layer that are here, because I want to take these 2 guys, and I'm going to right click and move them to that 2-rail sweep rails layer. 2-rail sweep rails layer. Okay, that way I'm able to turn them on and off when I need to, and that way they're in this color here, this blue that I've got set up for that layer, so that you can see them a little bit more clear. Okay, and so we'll get all centered up here now. Now I have other layers here, layers that were created when I brought that DXF file, when I brought that into my work area. It created these 3 layers here. that were created with that DXF. And so my actual model, my component leg is actually on layer 1. And we're going to right click and rename this to our component profile. Okay. Now this layer 0, we can go ahead and just right click and delete that. We don't need that visible because there was nothing on it. And layer 1 up here as well. We don't need that also, so we can delete that as well. So now my bounding box layer, that is just a bounding box. It's just a border of my 32-inch area here. And so I'm going to leave that in there. We won't use that right away or anything, but that's what that bounding box is. If you can see that red line, barely see that red line that's come up around the perimeter, that's what that bounding box layer is. All right, so now I've got my 2 rail sweeps. I got my component profile. We're going to go ahead and sweep this part. And on this part, when I create it, we're going to go into the modeling tool of the 2 rail sweep. We're going to select our 2 drive rails, and we're going to use that as our selection. And then we're going to take our profile here and we're going to sweep it between those spans. We're going to, it's going to be an add mode for right now, and we're going to click apply. So if we were to look at our 3D view here, we will have our, our profile. Now I'm going to tile this with the windows over and under one another. So we will be able to see that 3D view and our 2D view here as well. And we don't need the 3D view quite so big. Let's see if I can, there we go. All right, so you can see how we're working with it and stuff. Now, if I were to wrap this project right now, if I were to wrap this leg here, I'm going to close this tool, and if I were to come into my toolpath drawing and wrap the Y values, make sure that window is active in order to do that. Wrap the Y values around the X-axis, and we create that wrap profile, you would see the federal table leg in its wrap state. Okay, but this top part, this apron part here, this needs to be a square blank. And so what do we need to do how do we get that from a round stock to back to a square, for our square post, let's call it, our apron post, if we want to, if we must give it a name. Now I'm going to turn off the wrapping. So we're going to go with the wrapping off. And on my component here, I'm going to right click and I'm going to rename this. This is where we start kind of now getting a little bit more involved with the designing and everything. We start getting a little bit more involved with the, rather than just using the default names that the software creates for us, we start to kind of really name our parts, and we start giving, we start getting more into the detail of things, when we're setting up our files. So we're going to call this our federal leg main profile. Okay, and that's going to be in our basic shape, that level 1. We're going to rename that level, and we're going to call this our basic shape of our model. Okay, and now we need to get set up to create our unwrapper, our vector, for this square area up here. So, but before I do, I want you to notice something. we have a on this 3D model, we have some flat areas and stuff, especially this main flat area here, that we could optimize our toolpath. There's no reason why when we're creating our model and everything, and doing our 3D cut, and this should apply also for a taper versus a flat area. But our 3D modeling, when we're creating our 3D model, we want to create some vector boundaries for that 3D model, to come up, because this is a flat area. We can pocket this out. We can, do what have you. But now, if it's a flat, and I do not, and don't let me not confuse the situation. It is a flat, but it is actually a taper, so this might not apply. But if this section was completely flat, let's get into our full-on x-axis, oops, wrong axis, y-axis view here. We have a flat here. And so if we were machining this as a round toolpath without being square, if it was going to be a round leg at the top of this post, then we would not need to put that in the 3D model. We could just pocket that. There's no sense in wasting the time machining that area. This is the profile area we definitely need to machine, and this curve in this profile area. I do believe that since this part is not flat, then we wouldn't be able to isolate this from the model, but we're still going to draw those vectors in anyways. And those vectors, let's go back into our full 2D view here. We're going to temporarily shut off this level, this layer, to hide this component. So we're back to our blank board, and we're going to open up our polyline tool again. Now on the polyline, we're going to create another layer, and on this layer we're going to come in and we're going to call this our model boundaries. Okay, we're going to give this color that we can see. Let's go with kind of an aqua. Let's go with a turquoise. It's kind of bright and bright. We'll give that a color, so everything we draw on that layer will now come up that color. But what I want to do is, if we zoom into our model right here on this corner point, I want to wake up that point. I'm not clicking. You don't click. You just hover your mouse over with your smart snapping and wake that vector up. That way we get this vertical line here. And this will let me know where I'm going to snap to for my start point. Okay? And now I can continue on with that following that horizontal line. And when I get to my other end here, I can snap to that and then space bar to finish that off. Okay? Now let's come over, and at the other end of this model, right here on this corner, we're going to wake it up. And again, we're going to come in. Now notice, there we go. See, we got an angle here because it is leaning at a bit of an angle. We want to be 90 degrees straight up, that 90 degrees line there. And we want to snap. Now from there, we're going to come up 90 degrees, snap to our end point, and space bar to finish. We're kind of creating quadrants and things here, little areas to work with. At this corner here, we're going to wake it up. And notice now, because it's on a taper, notice that 90 degrees is actually at an angle. Okay? I'm looking to go straight in. I'm not coming at an angle here, for my leg. That's the 90 degree angle. You see that little 90 degree mark that pops up? That's 90 degrees on that taper, but I'm looking to come straight in alignment with that part. We're going to snap, and then we're going to come up and draw 90 degrees straight up and snap to there as well. All right, a couple more spots. We've got, let's come in here and see if we have kind of a defined corner. We really don't. That is actually one whole component, so we will just, we've already got our end rail there, so we will have that as our boundaries. Okay, and then this, from this point to this line, will be the boundary lines as well. All right, so we've got our kind of our boundary lines. Now we don't need them turned on right now. I just wanted the layer visible while we were creating those. They will come in use here in the future. But we're going to go ahead for right now. We're going to turn that layer off and hide them. We already have our 2-rail sweep and everything done. So we don't need our 2-rail sweep rails on anymore. So we're going to turn that layer off and hide those. Now what we need to do is, now we need to focus on this square area here. And what we need to do is we're going to grab the measuring tool, and let's get into a layer. Let's go ahead and get into our component profile layer to make sure that's what the layer we're working in. And because we're working with the component profile now, but we need to, from the center point of our model, which is represented by the end of this vertical leg here, that's going to be the center of our spindle. You know, if I were to have that line, you know, all the way across, that's our center of our spindle there. Well, we want to measure from that point to the highest point. So basically from the lowest point of our model, which is the center, to the highest point of our profile. And so if we measure that distance on our Y value, we have a distance of 1.75. Now we're going to double that number. We're going to double that number when we create our box for the vector unwrapper. Okay, so 1.75, which is going to be 3.5. So let's go ahead and close our ruler, keeping in mind our measurement of 3.5, our number. We're going to come in and open up the rectangle tool, and we're going to create a rectangle that is 3.5 by 3.5. Okay, I'm going to go ahead and make sure the center of my rectangle is at going to be on the center of my board. So let's click create. It's not center of my material, so we are going to select it and go into the alignment tool and make sure it is center. It must be in the center of your material in order for the vector unwrapper tool to work. Okay, in order for the vector unwrapper tool to work, this boundary box that represents our square blank here, or a post, let's call it, must be centered in order for using the vector wrapper tool. So now that we do that, we're going to go ahead and go into gadgets, wrapping, and vector unwrapper, and we're going to go ahead and click that. And let's see here. Our profile selected for unwrapping does not fit entirely within the cylinder diameter. So that is crucial. That is absolutely crucial. What that means is if we had a cylinder, we're going to draw this out so you understand. If we had a cylinder and we snap to one of these corners here, okay, our cylinder, our shape, our rectangle does not fit entirely in our 3.5 inch, you know, by 3.5 inch cylinder. Okay, the diameter that I set up for my project was 3.5 inches when we just set it up. Well, this is almost a 5-inch diameter. Almost a 5-inch diameter circle. So let's look at our size tool and let's make sure that I didn't mess up. There's okay. It's 3.5 by 3.5. Just making sure. So it does not fit within. Because if I draw this out, let's undo that circle. If I draw out my 3.5 inch diameter spindle, and I'm going to come in here and type in 3.5 D for diameter, well, that round cylinder that's getting cut, my box here does not fit anywhere inside of that. The circle actually fits inside the box. So the diameter of my stock needs to be wider. Okay, not 3.5. In order to cut this part out properly, it needs to be wider. And so let's find out how much wider. Let's go ahead and draw our circle, snap to the center here, and I'm going to snap to the corner. And so we're about 4.9. So if I come in here and adjust this to 5 inch diameter, you'll see that we have a little bit of room on each of the corners, you know, so that when this round stock gets milled down and everything, that our square blank, our square post can get milled out of it. You know, so we want that little bit of room, you know, so we don't get flat spots and things like that. So our diameter for our stock needs to be 5 inches in diameter. So if I come over to my gadget and my wrap job setup, let's see here, we might have to go into here, our job setup. First of all, we need to change our height, which is our circumference. So we got to go 5 times P for pi equals, okay, and we need to, the thickness of that center is going to be 2.5. Half of the 5 inches. All right, that's the center, 2.5. And let's click OK. All right. Now we need to make some adjustments. And we're going to go ahead and we're going to delete the unwrapped vector drive rails layer that was created when we did that vector selector. We're going to go ahead and delete that and delete the data. We're going to come in and once again we're going to center our part on our material. Must be center in order for this to work. And we're going to go in once again and we're going to go into our, let's create a new layer for this part here. So let's add a new layer and we're going to call this our vector unwrap box profile, and let's make that active, and let's put this part on that layer. So I'm going to move, right click on the part and move it to that layer.
Call from Ray Blunt.
Stand by, ladies and gentlemen. Okay. All right. So I had to wait while someone grabbed the phone. Okay. Now, once again, we're going to go into gadgets, wrapping, vector unwrapper, and as we click that, you'll see that we get this funky looking wave vector. Basically, that's this box unwrapped. Okay, that's this box unwrapped. All right, so now that we have that, I'm going to go ahead and select on this profile, and using the shortcut code of the number 9 key, I'm going to rotate this, and it's going to rotate in 45-degree increments. So I'm going to hit it twice so we can turn it 90 degrees. A little bit of a little trick there for you. Number 9 key when you're in the transform mode, when you double click in transform mode, the number 9 key is a 45-degree increment rotate pattern. Okay, so we're going to rotate that out. And we're going to go ahead and take that part and we're going to drag it down. And we no longer need our vector box boundary, so we can go ahead and delete that. Now, when I unwrap this, it created 2 drive rails, vector unwrapper drive rails. And we do not need them anymore, so we're going to come over to our layer tools, and the unwrapped vector drive rails here, we can go ahead and delete that layer and delete the data for it. We don't need those visible. On here, it also created our unwrapped vectors layer here, which is our unwrapped vector. That's the layer there. So we want that to be visible. We want to make sure that that's active right now while we work in it. And I'm going to go ahead and move this. I'm going to put it in transform mode, and I'm going to take and I'm going to move this over and kind of get in line with this guy here. Doesn't matter where, we're just going to use that there. And what I want to do with this is that's going to be my 2-rail sweep profile. But first, I gotta create those 2 rails. And how we do that, once again, we're going to use our polyline tool. Now this time, when we create the drive rails, we're not creating them along the work area. We're going to create them along the length on the x-axis. And we're going to use our profile here to help us out. So I want to wake up this corner, and I'm going to come over here and I'm going to snap to that edge to create that starting point of that polyline. And I'm going to come over here and I'm going to wake up this corner and just drag my mouse up till I'm in that horizontal plane and left click and spacebar to finish. Now at the top of my part here, we are going to come in and we're going to turn on our, not our model boundaries, our 2-rail sweep boundaries there, so we can see kind of where we need to stop from and all. And this, let's see here. Do I want to run the whole side? Bear with me a second. Yeah, I'm going to run the whole length, so I'm not going to use those right now. So let's turn that back off. Turn that back off, because we're going to end up sweeping this profile all the way across. All right, so I'm going to come up here to the top of my part. And again, I've got this vector kind of woke up, so now when I come in line with it, you can see that dotted line, letting me know where I'm at. So I'm going to come over here and I'm going to left click, and again I'm going to wake up this into this vector here, so that way I can just drag right up and make sure that those 2 parts are in line with one another. And those are going to be my 2 drive rails. So I've got my drive rail here and here. Now, for this, we're going to go ahead and create a new layer. This layer is going to be our box component. If I click on add new layer, where it's going to be called box component, let's do that again. Box component. And in our modeling, we're going to turn our model back on so it's visible. And we're going to end up recreating this model so it sweeps all the way across our profile. It was a little shy there. I was a little short on the diameter. I had my diameter wrong. Did I have my diameter wrong? Stand by, ladies and gentlemen. I'm thinking here for a second. I'm going to leave that model in there just in giggles. I want to test something out here. And oh gosh, did I stump myself? My vector unwrapper needed to be within a 5-inch diameter cylinder to get the 3.5 inches out of it. My 3.5 inches is going to be cut in the middle, so that is going to be in the center. Yeah, I need to take that component and I need to sweep it all the way across. So let's let's turn on. I didn't mean to confuse you guys. Sorry about that. Had myself confused for a moment. I need to turn on my 2-rail sweep vectors here, and I need to extend them. This is where the extend tool comes in handy. Let's get those visible and turned back on. I'm going to turn this layer off for a minute so we can see our 2 rails clearly. I'm going to make sure that I'm in that layer, that active layer, because I'm redrawing these. And I'm going to extend using the extend tool right here. I'm going to extend that rail to there. And I'm going to extend by clicking on the end here, and I'm going to extend that. Notice it's not giving me any, finish point here. So I need to cheat and create a little polyline right along that horizontal plane, kind of. That way it gives me a boundary for my extend tool to snap to. There we go. And now I can delete that little line there. Now with that extended, let's go ahead and first off, let's create our model again. So we're going to select on our 2-rail sweep tool. Turn our layer back on and turn this model off for a minute. 2-rail sweep tool, and we're going to go into our drive rails and use that selection, and then our profile to sweep between the spans. We're going to scale this to an exact height of 1.75 and click apply. Let's look at our model here. Alrighty. We're back on track. We're going to close that tool for a moment. We're going to delete this model, the first one that we created earlier a moment ago, and we're going to rename this one Federal our federal leg main shape. Alright, now I had us off track for a minute by creating the part too short. It wasn't the right diameter, but as you notice, when I created that part, I limited it to a shape height of 1 3/4. Okay, 1 3/4. All right. And that way, that's what I want my part to be. 1 3/4 and 1 3/4 is 3.5. All right. Now, back on track. Let's turn off that 2-rail sweep. Oops, our model got put on there. Let's move that sucker. Let's move him to his component profile. Right? Is that the right layer? Let's make sure. Model layer 1. Yeah, component profile. And that way we got that. And that way I can turn those drive rails off. I do not need layer 1. I don't know why that's in there. Let's delete that. Trying to clean ourselves up. Vector unwrap box profile. We don't need that anymore because we deleted that box. And our box component. Let's see which one alright, that's our unwrap vector. The box component is blank. You see these sheets of paper here, these sheets, when there's something on them, that means there's data on there. Well, I'm deleting all of these layers that have nothing on there, you know, nothing that we want. All right, ladies and gentlemen, back on track. The two horizontal boundary lines which correspond with the length of our part are drawn. These are going to be our drive rails. So we're going to open up that 2-rail sweep tool again, and we're going to select on those 2 drive rails. And I apologize. I know you're like, oh shit, he lost me about when he stuttered a minute back. But let's try to get back focused on track again. These are our drive rails. We're going to use those as our selection. Our profile, our unwrapped 3.5 inch by 3.5 inch square is going to be swept between this profile. So now we want to sweep between the spans. Okay. I'm not going to limit the scaling. I want it to scale to its full height because we've already got it sized appropriately. So this is going to be applied. Okay. And if we were to come in and that component, we do not want it. We're going to create a new level. This component's name, we're going to rename this as our box component. And I'm calling it a box, post, whatever you want to call it. It's a box, basically an unwrapped box. And we are going to, on the level, we're going to create a new level. And we're going to rename this level to our box shape. Okay, we got our basic shape and our box shape. I'm going to go ahead and drag this component up onto that level there. And that way I can hide the lower level so we can see our model for a moment. Let's look at it in the 3D view. So we've got this odd looking shape here. Now if I were to wrap this, let's go into the wrap our Y values around our X, you'll see that we have that square shape that we're looking for. Okay. Oh, Wayne. Jeez Louise. You guys are killing me with these shots. Alright. Let's take a break for a second. And you guys ask questions or let me know in the chat before we move on. Because of the little mix-up and stuff with the size of the board, did I lose you guys? And if so, what did you not catch or understand? Because I really want y'all to understand this, because there's going to be times where if you ever decide to use your 4th axis and you've got a square part, you know, your apron and everything, this function is going to be important. You know, how we do this. How do we get that square part from a round stock? You know, so let me know if I need to kind of recap this if I need to explain something a little bit more involved, or if I just need to keep going because all is good. So let me know in the chat. While you do that, I'm going to check out our Facebook group video and see if we have any comments over in the Facebook group video. So far, so good. All right, no comments over there. All right. All right, Dennis, so you got lost when I said fourth axis. All right. Would it be easier to account for the square stock prior to the 0 of your leg model? So, okay. So what Stephen Allen's question is, hey, if I'm going to be creating a model, and let me turn off this component for a second. Let's say that from that square blank, from this point on is going to be my model. Well, couldn't I just come in and account for this on my square blank? You know, add that size. That top part's going to be square, but I'm going to go ahead and model just from, and let me come down here in this vector and go into node editing, and let me cut it right here on the corner. And I'm going to take and create another 2-rail sweep. Let's go into our components and let's insert another level, and we'll just call this level our example. Rename. Example, let me learn how to spell example. All right, we'll just call it example model. I can't think of the proper term for this. But if I go into my 2-rail sweep and I select my component here, from this point to this point, and that's my drive rails, and I select my component here. Now, the one thing that I'm missing is the leg of this component. It's because I just cut that leg off. So before I go any further, I need to stop, and I'm going to make a copy of this. I'm going to go into Shift Control, and I'm just going to hold my Control key down, and I'm going to drag a copy up top here. Okay, and I'm going to well, that was dumb. Let's undo that. I need to draw my leg first. Alright, so let's go and we're going to snap to this point, and I'm going to wake up this vector right here. That's my center line. Wake up that vector, and I'm going to snap to that center line and spacebar to finish. And if I take these two guys right here and go into transform mode and hold my control key down and drag that copy of those two just kind of up here. I'm just bringing them up here. I can join those two together as one open vector. And the reason why I'm doing that is so that my federal table leg can stay intact. And now I have a copy of just the bottom part. And I want to, move this over. I'm going to kind of snap to this here. And let's go back into that 2-rail sweep tool. So I'm going to go to my 2-rail sweep in the modeling, and I'm going to go and open this. Click on this for my drive rails, my profile for the profile, and click apply. Let that sweep along. Okay. If we look at our 3D view, we're basically kind of just accounting for that lower half of the model because our stock is going to be that square remaining part, and we're just going to zero out the x-axis or start from this point when we do our machining boundaries. Stephen, yes, the question is can we just account for that with the 0 of your leg model? Now you would still zero your model out, your out. You would not zero from this point, of this model. you would still zero out from the the start of your project board, or here, this bottom left corner. But we would create a vector boundary, and when we machine or create the toolpath for this, if we were to create the toolpath, we would use our drive rails. Let's deselect this for a moment. Let me close this tool I have open. Let's close that. There we go. We would select our drive rails as our kind of vector boundary. So if I get a 3D finish cut, we need to turn wrapping off, so we'll let them do that. I would use the selected vectors as the boundary, and in this case I'm rastering back and forth along that x-axis, limiting to there, and I would calculate this toolpath. Now, 2 open vectors, right? We cannot create, or use those vectors are going to get ignored. So we have to close them off. And so by closing them off, we go into our join with a straight line, and create that box. Okay, that box now. Now I can use the selected vector as a boundary, and I can calculate that section of the leg that's going to get cut. So let that model create. So yeah, Stephen, would it be easier to account for the square stock prior to the zero of your leg model? And just focus on, from that square stock 6 inches down. I need my apron to be 6 inches. From that 6 inches down is going to be model carving, and that's what I want to carve that model out and everything. Yeah, you could do that. Would it be easier? Sure, but we're going to be truing up our stock. And so therefore, when we true up our stock, we're going to be rounding it off. And with the rounding toolpath, so now we got a round blank, and we need to get back to square. You know what I mean? So just like you true up your lathe, you true up your stock and everything. That's what we're doing, and that's what this is kind of referring to. With when we true up our stock by 0, doing that rounding toolpath and get it round. Now we got to get back to a square post, in that apron post. Well, Steven's question is saying, well, can't we just, have our square blank and then just do the modeling on the back end? Yeah, absolutely. That would mean we're kind of bypassing the truing up part, but still is what it is. All right. So the only part that is getting modeled is that part there. And of course, I was modeling along the Y. I should have been modeling along the X, so I'd have to change that in my toolpath. But let's wrap this up. And we're only cutting that part. That model part. The rest of it's going to be that square blank. So yeah, we could account for that in that way, Stephen. But this is how to get from that round, trued up blank to back to a square post, if that makes sense. Now, let's see here. I will watch the replay tomorrow. Yeah, JB, this is similar to the leg that we drew and designed in the shop, the federal leg table, and so the just exactly similar to the ones that we created and stuff. The Now, agreed. I started with a machine square blank and started my model at the first rounded object. There you go. So, JB, you actually carved this leg, and you started with a square blank, and then you started the modeling from that point. Give some feedback give some feedback and see if that method worked for you, how the table legs came out, or what have you. But again, if we trued up our stock and then did around, we have to get back to that square, and that's the method that I'm teaching with the vector unwrapper. Yep, okay. As the job ran. Now, it works with this leg, but other styles, I see what you're saying. Yeah, absolutely. Most legs will attach via apron hardware. Yes. Yeah, absolutely. Most legs will attach via apron hardware. I will post photos of the legs in the Facebook. Cool. Well, that's awesome, JB. If you do that, that was cool. That'd be cool. So they can see. JB is, he and I had, kind of worked on this profile, this leg, and I think he made 4 of them, or 6 or 8, however many you made, JB. But what we're trying to do now is let's take a look at, so we've got our profile here, this is the bottom half. Let's kind of turn that layer off. Let's go into our modeling. Let's go back over to the side, and let's talk, let's kind of combine our box component and our leg shape component and see what we come up with. So let's turn this level off of that sample, okay? And let's go ahead and turn off our 2 rail sweep rails. For the time being, and let's turn our component back on, our basic shape. All right, so if we look at our 3D, let's go with a side by or tiled view so we can see what we're doing here. Let's unwrap this view. Turn that wrapping off, and let's close the preview window so we can get back to our model. So here's our model here. All right. If I were to create a toolpath for this model, all right, if I were to create a toolpath for this model, now that our full leg table here, if I come into that 3D Finish toolpath and create a model for that using the model as the boundary in this case, and we click calculate. Let that calculate, and then we're going to put in the box shape component that we created to create that, to get that square blank. We're going to blend those 2 components together in this model. So let that calculate. Give it a second to calculate. While that happens, let's see what we got here. Dennis, how you doing, buddy? I hope you're doing well. Almost there, guys. It's calculating. It's calculating. It's a calculate. It's a calculating. Had to pause. It had to pause for a minute, then it started going again. Had to take a break. That was a long line to travel there. Let's see here. Doing it that way is how I do it on my manual router lathe. There you go. Done. Doing it that way is how you do it on your manual router lathe. Doing it the where you have the square blank already kind of accounted for it, and Doug, where you just kind of mill and model the modeling area, that taper and those coves and everything. Is that what you're referring to? All right. JB, are you telling me to check them out, or are you telling the guys and girls to check them out on the posted Facebook? All right, let's reset our preview back to a blank board, and let's preview this selected toolpath here. And again, I'm machining along the y-axis. I should be machining along the x. Remind me to change that. All right, so now if I were to wrap this leg as if it were being milled, if I were to wrap this leg, you know, we have that round stock there. You know, we need that square. So let's go ahead and 0, 0, 0, unwrap, not 0. Let's go ahead and unwrap that. And let's bring in our box component. So let's turn that layer on. And let's close our preview so we can see our model. When you're doing a model preview, if you want to go back to see your model, close the preview window over here so you can see our model. And now we got this funky looking shape, right? Well, what it's doing is this particular box shape level, is being added. The combined mode of that level is being added to the basic shape level. So what we need to do is on this level, and that's why you get this, you know, it's adding on top of that level there. So what we need to do is we need to change the combine mode of that from add to merge. Okay? We have a more appropriate looking part there. All right. Now let's go in and let's come over to the Toolpath side. Once again, we're going to create a 3D finish toolpath. There's 3 3D finish toolpaths. And by the way, let me change this to 0, raster angle 0. The 3 examples, those 3D finishes, we have 3 different examples. And so I'll rename them as well, so you know, you guys and girls know what they are. But let this model out. Almost there. While it goes, thank you, JB, for clarifying that. Awesome. Guys and girls, JB posted pictures of the legs in the Facebook group for a better visual of the federal legs that he created. If I'm not mistaken, correct me if I'm wrong, JB, you made those out of kind of almost like was it a spalted maple that one time? They were really pretty wood, whatever it was. I can't remember off the top of my head, but it was super, super nice looking. JB right out of the gate, everyone. JB's awesome. Right out of the gate, he got his CNC. Did some training, you know, on the newer model CNC with his fourth axis and all. First thing he did was the 4th axis. Many people, there's many of us that had the 4th axis or have had the 4th axis on our machine for a long time and have not used it yet. Or you know, haven't had the opportunity to use it or anything. JB jumped in feet first, and it was, I think, it was pretty close. It wasn't the first project you created, first projects, but on that new table, it was the first project. So if I'm not mistaken, correct me if I'm wrong on that you created, and just jumped right in feet first, and they came out really nice. All right, so we're about at the finish line of this generation of this 3D toolpath. There you go, Steven. Yep, I had it for 4 years. I had mine for Oh gosh, I had to use it kind of right away to make a video and stuff, but I don't get to use it that often, so it's almost like a new experience every time I do. So let's reset that preview back to a blank board, and let's preview this selected toolpath. So those humps, those tops of those waves you're seeing there, that represents the corner of our square blank. So what you're seeing, remember that rotary axis is revolving. So the little U-shaped curves, those are the flats. And then those rises, those high peaks of the component here, those are the corners of our four corners of our post. And then these are the flat areas here, that are, revolving around. That's what you're seeing there. That's what that wave formation is. That's our four corners. All right, let's go ahead and wrap this up. There we go. And so now, what do we do about the start and the finish of this? We're going to cut them off and all that. Do we want to create a little bit of a space here? Since we're using the model as a boundary, do we want to create a little bit of a space like a tenon that we have to cut off and things? Well, then, yeah. Rather than having to, just cut that off, we can kind of mill it down a little bit to make it a little easier to remove. So if we come over here on this part, if I come over and we're going to draw a box, let's go into our drawing tools. And we're going to kind of, from the corner here, I'm going to kind of wake that up. And also from this corner, I want to kind of get that intersection here. We're going to kind of create a box, and we're going to kind of wake this bottom part up here. And on the height, I'm going to keep the height how it is, but the width, how wide do I want that tenon, or that end to be? Let's go 3/4. Okay, and click apply. And I want to move that bad boy over. Let's zoom in and let's move it over to our 0 line. There we go. And now we're going to come in and create another rectangle that's going to represent our tenon. So let's say that I snap to here and down. That tenon would be 5/8. Let's give ourselves a little bit of a shot. Let's go 3/4. 0.75. And again, we need to we can close this. Let's snap to this bottom corner here, like that. And now let's do some interactive trimming. So we're going to come over here and we're going to trim this. Oh, not that. Let's first do some node editing here. On here, I don't know why my node editing does that. Let's select this first and do some node editing. This span here we do not need, so we're going to delete that span. Okay. This span, or this part here, we're going to go ahead and right at this line, we're going to cut the vector there. On this part, this span we do not need. And we should be able to now come in with our interactive trim tool, and we should be able to trim away that line and that line. Okay. All right. So now we should have one profile. Awesome blossom. Okay. Now on my component on my 2-rail sweep tool. Let's bring all of these right now are still kind of, let's see, is it all joined together? I got to join this with this. So let's join that as see what my open vectors are. Bear with me a second. I've got one open vector. That's correct. And if I join that with this bad boy, it won't let me join. So let me see what I've got a little bit of an overlap somewhere. Let's come on over here. That one's good. Right there's all sneaky overlap. Barely see it. Let's maximize that view so you can see this. Let's maximize that view. See that little bitty stab of an overlap hanging up there. We're going to go in to our interactive trim tool, and we should be able to trim that little nub away. And now that should close that off. There's always a reason for something. There we go. Good. All right. So what we're going to do now is, now that we've added that little tenon into the work, into the kind of the workflow of things, basically, we need to kind of create this model to add. We're adding that tenon in. We could do the same thing on this side as well, but this is a little bit narrowed down, a little bit smaller. If we look at our 3D view here, that I can kind of I can trim down easy. This one's a little bit tougher to deal with. So let's go ahead and create our drive rail, our line, our drive rail here. And notice that I made a mistake. I clicked at the top. I'm going to start down here with my drive rail, just like the same way I drew the other lines. You always want to draw your lines in the same order so all your start points are the same. And let's go into our model, make this layer active, and turn this model off for a minute. Let's turn this one off for a second as well too. We're going to use this drive rail here and our end rail, but remember our end rail, we kind of created this box with it. So let's cut that node up and get that end rail back. Cut the vector there. Cut the vector there. All right. So this vector and this vector are going to be our drive rails for our 2-well sweep. And we're going to take this component and sweep it between those spans. All right. So if we look at our 3D view, you can see that model, that tenon that we kind of created, and make it a little bit easier to kind of, cut that tenon loose. You can make your tenon smaller or whatever. I like a little bit of beef on my tenons. But let's unwrap that for right this moment. And now if we turn our box shape back on, we've got this would be our finished model here with that tenon kind of already cut in there to be able to cut it loose. We could do the same thing at the other end with this extra area here, this extra room. Our end cap doesn't need to be that thick, but let's go ahead and create I'm just going to recalculate this finished toolpath. And all I did by adding that little end cap on there is just to kind of mill some of that material away so I can cut that leg loose from the two waist ends. On my tailstock and my headstock, I just can, just kind of mill it down. It's going to be a 3-inch tenon, or a 3/4 inch tenon that I can just cut loose. All right. So JB said, I'm just catching up with the conversation. Safe height was an issue when I got mine. The safe height needs to be high enough not to top off one of the corners at the apron stock. Yeah, we haven't talked about the safe height yet. We're gonna definitely talk about that in just a second. The safe height, guys, what that's talking about is like when you're milling on the flat table, you have the safe Z height that when that router's moving back and forth, what a distance being away from the router would be when it's traveling back and forth. But you also have your start height, okay? Your start height. When you hit that start button, how high that router raises up when you hit that start button. We don't want to raise up too high, when we're on the flat table because we hit our Z limits. Well, when it comes to the fourth axis, we want to make sure that our start height, or our start distance, we'll call it, it's the start height, but our start distance, we want to make sure that's far enough away from our stock that, we don't, when that router turns on, it doesn't, cut into our stock. But also when we're traveling back and forth, not cutting, that we're clearing our part, as it travels back and forth when it's in its rapid modes. So that's what... Yep. All right, so we're almost there. Another little quarter of an inch. All right, here we go. All right, let's reset that preview, and once again from a blank board, and preview that selected toolpath. And see on this part here down at the end, we could actually create another shape, and we can make that tenon a little thinner down on this end as well. But not necessary. All right, so now the reason why this kind of falls into that safe height, JB. The reason why our stock diameter is 5 inches is because those corners, you see how high those corner peaks up. When that corner comes around on that square blank and everything, watch as this corner gets cut. There's not very much material right there. I mean, it's just a very small amount of material from that corner that's getting milled away to, to create that sharp point. So that this part has to fit within our material. You would think, my goodness, why if my leg is 3.5 by 3.5, do I need a 5-inch plank? Well, we've got to be able to get that that 3.5 and 3.5 is on your flats, right? Measure from corner to corner your diagonals. Measure from corner to corner your diagonals, and you're running tight. We'll take a look at that in the 2D view after this is almost done. All right, so what do we got here? Any comments or feedback so far? You guys, you keeping up? You liking this? Is this boring you to death? Where are we at? Give me some feedback. I want you guys to stay awake and alert. So talk to me. Let's look at our Facebook group. Let's see if we have any comments on here. Mike Glad. When this is cutting on the router, the bit is moving back and forth along the x-axis. Yes, that is correct, Mike. And when it gets to the right-hand side, the bit is cutting the full depth at once. No, this is a finish cut that you're seeing, Mike. This is a finish cut. that full depth on that right, we would be doing a rough cut to rough away that material. I have not created a rough cut. I'm just showing the finish cuts. But in just a moment, we're going to create both the proper roughing toolpath that hogs away that waste material and the finishing toolpath. Okay? The roughing and the finishing. All right, so now that we have that part, let's go ahead and wrap it up. That was a great question, Mike, because everybody would probably think that's exactly what was happening. But no, it's not taking that full cut. So now we have our, end piece. We might even change the stock on the bottom end too. But now we've got that little tenon we can now cut away, from that top piece there. Very easily. Wonderful, wonderful. And we have our square leg and all that wonderful jazz. All right, Tamara. It looks good. Someone call my husband and tell him I need a 4th axis. Oh wait, I have a bunch of lathes already. I have a lathe too, Tamara. But the one thing that I cannot do, we got some buffering, guys. Sorry about that. The one thing that I cannot do is turn 4 consecutive parts. With the 4th axis, I can turn 20 of these legs, and they're all going to be pretty much the same throughout. The only thing that's going to be different is the grain of the wood, the type of wood, and all that stuff. When I ran it, we came down 5 inches on the apron stock and ran the rounding toolpath utility for the rough stock. This was done with a down and a bull and tray bit. Then we ran the finished toolpath according to this. Exactly. All right. Now, what we're going to do is, in this case, JB, we would actually run the entire rounding toolpath to true up our 5x5 inch blank. True it up. And then from there, we would do our rough and finish. So, but before we get into that, let's talk about our job setup here, because that's what it's all kind of leading into. Let's close our preview, and let's turn our wrapping off here. Okay. All right, let's get our part kind of laid out kind of in front of us here. Okay. In the material setup, okay, my stock thickness from the center axis, from the center of my stock out, is 2.5 inches. All right. My safe Z height, my clearance Z height, my rapid Z about gaps material is set at 0.2. And the plunge is set at 0.2. And then my home start position is 0 on the X, 0 on the Y, and 0.8 on the material. Now, because I am referencing off the center of the stock, the bottom of that material, if we look at the home position, it has added some heights for me. Okay, so that Z height, instead of 0.8, it took that 2.5 inches and added that 0.8 to it to give it that 3.3, that clearance on that home start position. But it did not change my material position, because from the surface of my material, not from the 0, but from the surface of my material, that 2.5 inches, it's keeping that distance of 0.2 away from the surface, from that 2.5 inches from center. Okay. Now, for more comfort level, let's give this a 1 inch Z gap above material. Now I'll be at 3.5 inches away. And on the clearance from the surface of my material, let's give ourselves, 3/8 of an inch. Okay. And now it's going to ask if we want to recalculate all the toolpaths. I'm going to say no because there are 2 toolpaths in here that I do not want to recalculate right now. So we're going to delete them. So now if we look, we have a 3/8 inch clearance from the surface of our material when it's traveling back and forth. And so it's going to back up 3/8 of an inch and go, from one end or the other. We have a Z home position of a start and end position of 3.5 inches away. And that's, that's going to give us, our part. All right. Now, let's take a look at, now that we have our material set up, let's take a look at our roughing toolpath, okay? Now with the roughing toolpath, this is a roughing toolpath. I want to get this over as, as quickly as possible. So I'm going to use a large diameter bit. I am not going to use a 1/4 inch end mill to rough this out. I'm going to be at a 1/2 inch end mill, 1/2 inch ball nose. I might even use my bowl and tray bit to kind of rough this out. I'm not talking about the rounding toolpath. I'm talking about the roughing toolpath. But I want to make sure that my roughing toolpath, whatever bit that I use, that it can fit into these areas and stuff to get it milled down where it needs to mill to. So let's take a look at our, we'll use a 1/2 inch ball nose end mill for this. And we're going to use the model as a boundary. I'm not going to have an offset, no offset on that boundary. And I'm going to use leave an allowance of about 30 thousandths for that. I want to raster along the x-axis. I always want to cut with the grain of my stock, my post, my spindle, my what have you. And we're going to calculate that rough cut. Okay, let's move that rough cut back in the proper order it should be in. And let's take a look at this rough cut. So my end mill is going to be taking steps. Mike Glad, this is kind of what you were referring to. Let's look at our x-axis here. It's going to be taking past steps, multiple steps. So let's kind of look at what the simulation would look like with the rough cut. So let's preview the rough cut. Okay, so now it's going to kind of step down. And it's only roughing out the sections it needs to. It's removing the material it needs to. That 1/2 inch end mill is taking all that waste material step by step until we get with a rough piece here. Okay. From there, my finish bit, let's open it back up. We're using, in this case, I'm using an 1/8 inch ball nose end mill. Now, I can look at my design here and see if, my 1/8 inch, I want to use a small bit because I want to get into that detail in here and things. But, hey, what if I what if I create some boundaries here and use my small bit for these areas here, but use my larger ball nose bit for machining these areas? Right? So that way I'm not taking that 1/8 inch end mill along this whole path, right? So how do we do that? How do we set that up, to kind of optimize our toolpath? Well, I'm going to show you. So let's go in here, let's turn our 2-rail sweep tool off, and let's turn on our model boundaries. Remember those model boundaries? And by the way, let me turn that 2-rail sweep tool on so my tool comes back in here. Let's put that sucker back where it belongs. Move back to the component profile layer. There you go. All right. So if you remember, I cordoned off these areas here with, in these sections here, with these vector lines. And so we're going to extend them out. Remember, these were earlier on in the class. So let's get ahead. Let's go ahead and extend them out. So I'm going to pop open my drawing tab real quick, and I'm just going to snap a line from here to here, just for a moment. I'm going to end up deleting that line. And look, don't do that. Don't do what I do. You see how I had the 2-rail sweep layer on? Let's turn that back off. I want to make my model boundary layer active. Work in your active layer. Don't make the same mistake I just made. So model boundaries is active. Now I can come in and I can draw that line. When you see other stuff pop up on you, that means that that you've got a wrong layer active. All right, so now that I have that line there, now I can take my extend tool and I can go ahead and extend these lines out. All right, so let's get these extended out here. Excuse me. All right, let's close that extend tool. And I'm going to go ahead and grip my line polyline tool, and I'm going to draw a line here. And draw a line down here. And I might as well draw a line across here, which was my layer that was the vector boundary, that red layer. But that's well. No harm, no foul. All right, so these two guys right here, these two, we don't need them visible anymore. That was for the profile for the sweep here, so we can turn that layer off. That would be my unwrap vectors. Yep, see that goes away. Goody goody gumdrops. All right, so what we're going to do is we're going to take and we're going to do some trimming. So this all right. This rectangle here and this rectangle here. Oh, am I not joined there? Let's join her up. It's not joined. So let's grab this and hit this guy right here and one closed vector. So let's join that. All right. So these are going to be our machining boundaries for our smaller bit, where our small bit profile needs to machine. These larger areas here are going to be our larger boundaries. So we're going to go ahead and I'm going to open up the rectangle tool. And we're going to snap to this corner and snap to this corner. We're going to draw that boundary out so it's a separate vector. We're going to snap to this corner and snap to this corner. So we draw that out. All right, so now we should have 4 individual boundaries here. 2 of them are going to be for our model, our small bit, and 2 of them are going to be for our big bit. So we're going to come in here and we're going to create our 3D finished toolpath. 3D finished toolpath. We're going to use the selected vectors as the boundary, and for this one is going to be my my 1/8 inch bit. So that's going to be this vector here. Oops, not that one. This one here, because that model area, and this one here. Not that one there, Laney. This one here. There we go. Those 2. So this is going to be called our detail area 0.125 em. All right, let's calculate that. Now, comparatively, we're going to create a toolpath and see, how much time we saved by breaking this up and using 2, different, bits and stuff. All right. Okay. So there's our 2 toolpaths there. Now, originally our 3D finish, which was the whole model with the 1/8 inch bit, right? The whole model with the 1/8 inch bit, this guy right here. If we look at our time, 19 hours running at my speeds, my 1/8 inch bit, running 60 inches a minute and 15 on the plunge, right? Holy jamoli. Okay, well, the finish area here, we cut that in half. 8 hours, not 19, 8, right? Just by limiting that, to those areas. Now, our larger diameter bit, we're going to create that finish toolpath using the selected vectors as a boundary. This one is going to be our 1/2 inch ball nose. Same bit that we rough cut with, so we don't have to change bits. And that's going to be for this vector and this area. And we're going to calculate that toolpath. Okay, and if we look at our time on that, 2 hours. So ultimately, 8 and 2 is 10 hours versus 19. So we cut off 9 hours of time on machining time by separating that out. Now, let's preview these guys and girls, and let's make sure that everything looks good. Good. All right, we have our rough cut. Let's turn off our toolpaths for a minute. So we got our rough cut. That's our or our 1/2 inch ball rough cut that we created. Now we've got our 2 bits here. Let's preview those. All right, we need to shorten that boundary, and we don't want to mill away our tenon. All right, so we got to fix that one. That's our 1/2 inch bit. We got to fix that 3D drive. We don't want to mill that tenon away. Goofball I am. All right, let's fix that finish toolpath here for the small detail area with the 1/8 inch end mill. Let's go in here, and this we need to draw a little guideline right there. I'm going to cheat and just draw a little line there. You don't have to do this. But now I can take my box here and I can snap to that. Is that right? Is that right? Is that right? All right. Let's go in and select that little vector and delete it that I drew it in there. All right, one more time. Let's select our, not that boundary, this one here and that one there, and calculate that bad boy. All right, let's reset that preview, and from scratch here, we got our rough cut. Let's preview that selected toolpath. Our rough cut is going to come through with our 1/2 inch end mill. Now, since we have the 1/2 inch ball nose end mill doing the rough cut, we're going to just run the 1/2 inch end mill for the finish cut, that second cut with it, so we don't have to take that bit out or change bits or anything. We only basically have one tool change here, because I would use my 1/2 inch ball nose most likely for my round over as well, my rounding toolpath if I was going to do that. Let's go ahead and that 3D finish with that 1/2 inch bit, let's move that up since they're going to be together. And let's preview that selected toolpath. Yeah, I could do both ends. Yeah, I need to limit both ends and all to limit that boundary where it carves. You're correct. You are correct, Wayne. All right. And let's look at that detail area finish. Let's move this one down out of the way because that's that full-on one. And let's preview that selected toolpath. All right. Now, what Wayne was pointing out to me is, hey, why would on the 1/2 inch end mill, why would we not limit that boundary as well, bring that boundary in so that bit's not wasting all that time carving all of that? He's absolutely correct. So, because our roughing toolpath kind of takes care of this area here, and so if I come in, and let's see if I can wake that up and snap to that. There. We'll just very simply recalculate that. There we go. Let's take a look at what our times would be for something like this. So excluding the rounding toolpath, if we look at our times, we've got for our rough cut, based on that rough cut with that 1/2 inch end mill, based on the pass depths, do we need to, can we take a look at that rough cut? No, it's a 10-hour run, right? Woo! How do we optimize that? Because there's something we can do to optimize that cut a little bit better. Can we reduce the passes or the step over? Can we increase that? So we'll take a look at that one. The 3D finish, another 2 hours. So we're at 12 hours for this so far. And then our detail cut, which is 7 hours. So we're right back. Instead of a 19-hour, if I would turn these two off, with my rough and a full 3D finish would be 30 hours of runtime if I ran my whole 1/8 inch ball nose end mill across the leg of that table, right? But by breaking it up into a larger bit and a smaller bit section, we're taking that 30 hours down to 19. So so about 11 hours we cut off the time. But still, can we shave off some more? Right now the major time is the rough cut. What can we do for that roughing toolpath to eliminate some of the time? So let's turn off all these toolpaths here. And let's look at our rough cut. And let's see what we got going on here. So on that rough cut, if I look at the tool, my pass depth is taking 1/4 inch at a time. And I'm stepping over 10%, right? Well, that is my step over for my finishing toolpath. That's my step over for my finishing. I do not need to step over that little for the rough cut. So I'm going to come over and we're going to go 40% on this. And on the feed and plunge rate, we can look at bumping this up. It's a bigger bit, so it can handle bigger speeds. Let's go to 75 or 80. And the pass depth, quarter inch is about aggressive as I want to go. So we're going to just change that step over. Let's calculate that. Let's see if there's anything. We're going to do no profile pass. We're going to eliminate that. We don't need a profile pass for this. The finished bit's going to do all that. And let's calculate this up. Okay. So let's take a look at that roughing toolpath time. Remember, it was 10 hours. How much time did we shave off? 2 hours. So we shaved off 8 hours of runtime with that slight modification. Decreasing that step over, because I'm using a ball nose bit. And my ball noses have their finishing step over of 8 or 10%, 15 maximum. But on a rough cut, there's no need to go through all that. We want to increase that step over. So we shaved 8 hours off this. So now if we look at our total time, we've got a total job time of about 11 hours for this leg. You know, and on our here's our detail bit, 7 hours. That's the biggest run time. Well, what can we do? I mean, is there something that we can adjust to change that? So let's take a look at that detail area and let's see what we've got going on here. So if I look at my bit, I've got my bit running at a step over of 8% and 15. I like that 8% and 15. I don't like to do a lot of cleaning or sanding and stuff. But on the clearance pass step over, I can bump that up a little bit. We can go 25%. That's the clearance pass step over and everything. This, I can bring this up to 10%. My range is 8 to 15. I can go up to 10%, still get a nice looking leg. And I can bump this up, my 1/8 inch bit, I can run that about 65 inches. And let's increase the plunge to 20. That's as high as I want to go with my bit. So I'm going to click OK. And let's calculate that out. Now that was at 7 hours runtime. 7 hours and 25 minutes or something. With that slight modification. Let's turn off that toolpath there. With that slight modification and everything, speeding things up by changing my step over. Let's look at the time on just that finished toolpath, and I shaved 2 hours off of it. So altogether we're looking at a runtime of about 9 hours and 57 minutes. Conservative, being conservative. Now I could be much more aggressive on my depths of cut, and everything, but I don't like to do a lot of after finish work and sanding and all of that. So, but taking it from a 30-hour job down to a 19-hour job, down to a 9-hour job, just by making some modifications and adjustments and creating some boundaries and limits and using larger bits and smaller bits. I don't mind doing the bit change. It's only one bit change, one tool change here. From my 1/2 inch ball nose to my finished bit. I don't mind doing that tool change at all, to reduce my time and things, for sure. All right, so let's go back and let's see what we did. Did our adjustments in any way change the quality of our cut? So let's preview these toolpaths. All right, so let's see here. Andrew Price. Is that an 1/8 inch bit? This is a 1/2 inch ball nose bit right here. This one that's running on the screen right now. In the preview. But now what we just calculated, what you're seeing here, what we calculated is for an 1/8 inch tapered ball nose. Yes, sir. All right. So let's wrap this up. Okay. So the only thing I see for me is, and Metric's not really that great about showing end cuts and everything, but let me see what my quality says. Show preview. Okay, let's go to an actual representation of what our cut's going to look like. Let's go to a 98% representation here. Turn that wrapping off. Now, this is going to take a minute to preview, so I'm just going to go straight to the finish cut because the rough and everything, because I have the quality set so high, it's going to take a little bit to preview that simulation. So I'm not going to do the rough. We know what the roughing looks like. It's a rough cut. Okay, so can this method be used on any project you do to decrease your runtime? Sure, Wayne, why not? You can look at your project. You can look at your project and determine what you can do to optimize your toolpaths to reduce runtime. Absolutely. You can look at adjusting your speed slightly, your plunge rate. You can look at adjusting your step over or your pass depth. You want to, make sure that you don't overshoot it. Like if I have a 1/4 inch bit and say, oh, you know what? I'm going to take this 3/4 inch pass in one pass and I'm going to just take this whole thing. And, you're going to end up breaking a bit or something. But there's no need in, taking it in 14 or 15 passes. You can increase that a little bit. But yeah, you can absolutely use this method or this method of thinking. Boundaries, using the selected vector of the boundary when you're creating a 3D cut to reduce your machining time. Whether you were milling a 3D model on the flat table or the 4th axis, you can create vector boundaries around parts and that would be that a larger bit could handle just fine without messing up the detail, and then you could have the boundaries for where the smaller bit machines. Yes, different bit in certain areas, for sure. You got to create those boundaries. I could not just if I were to create 2 finished tool paths without having the vector boundaries selected, then it would be basically running 2 full tool paths on the model. So we have to use those vector boundaries so it only machines those areas with that bit. All right, any questions, guys and girls? It's getting 9:29. I want to, while this is machining, this is a perfect time to ask questions and get answers. And then I want to talk to you about what I said I would talk to you about at the beginning of this class. So let's see how many of you are paying attention. What the hell did I say I was going to do? I said that, what the heck did I say? Don't ever get old. I done forgot what I said. I said I wanted to show Dadgummit. Now I got to remember what I said. Anybody got a replay button? No, just kidding. We were doing the federal leg table. Oops, that's not the right one. And I said I wanted to show you about optimizing Toolpath in another way by using special profile bits. Right? How can we optimize our Toolpath by using a specialty profile bit? And that's what I want to spend the last few minutes on talking about. Yeah, Wayne, absolutely. Take a look at it and look at different ways you can use a larger bit and everything. The reason why this processing right now of this preview is taking so long because I have it set at extremely high. I want a 98% representation of what my project's going to look like, so I can see the quality of it. I can see if I need to adjust or change anything. So it's processing out. While that's processing out, I'm going to open another instance of Aspire. Aspire. Now, in something like this, we don't need Aspire. We could this method that I'm about to talk about. We could do this in Desktop or Pro. So let's create a new file. By creating our wrap job setup. And we're going to go cylinder diameter 5. We were kind of doing the same kind of similar tool. And everything else, all the defaults are the same, so we're going to click OK. Thank you, Jared. Specialty bit. All right. Let's import some vectors. These vectors, if I go into my Seagate backup drive and I go into some design CAD CAM, working with inlays, wall art. Bear with me. That was Mickey. That's my picture frame. What I'm looking for is my magnate file. If it's not in one of our past classes, I thought I shared that with you guys. Fonts, compass. Alright, so let's get out of that and let's go down to magnate. I should have that in my downloads. And it should be called not magnate but router bit profiles. Alright, it's going to take a second for this to import these router bit profiles, because there's a lot of them. Magnate is, it's a cool site that makes some nice tools and all, and they were very nice about taking all of their tools and creating a router bit profile for that. And so if we were to look at this, let's go into over here. So they actually created their router bit profiles, with the actual tool number and the description, right? How awesome was that? So all of their router bits, their roundovers, their custom based ball bits, they're plunge bead bits, all of that stuff. And we're going to use this, we're going to use these specialty bits to help optimize our toolpath. So the first thing we're going to do is we're going to kind of move those off to the side. And we're going to go in and we're going to pick a couple of bits. So I'm going to grab our classical spiral here. So we'll take that, not that one. And this is going to be a 3-inch diameter. And so I'm going to take that bit, and with it selected, I'm going to group those boys together as one because they're individual right now. And the reason why they're individual, I'll tell you why they're individual in a minute, is because if we were adding these bits to our tool database, we only need the right half of it, so that's kind of broken up for us. But I'm going to hold down my control key down because I don't want to move my menu, and I want to drag a copy of this bit over. So I'm going to use that bit there. We're going to grab, let's see here. I like this profile here, so I'm going to use this plunge bit right here. G for group to group that together. Double click on it to put it in transform mode, and I'm going to drag that over a little further. Drag that over. Alright, so we're going to do a nice this one here. So let me select this guy here and turn this one off. How wide is that one? That's a deep. That's 3-inch. Alright, so let's go with a smaller one on this. We'll grab this one here. Not these vectors. Alright, let me group that one together and double click to put it in transform mode, and control, drag that over, and this will be good for my leg. So let's drag that over to add with those three. Alright, so to start this off, let's grab these three guys here, and let's kind of move them, off to the side of our board here, and let's zoom in so we can focus on this. Now I'm going to take, and just to simulate this, I'm going to take and just draw a rectangle. Okay, and I'm going to have this rectangle be 32 inches. And 3.5 inches, and I want to center that, center, align tool, and center that. All right, so imagine that this is my leg. Okay, we're creating the profile for our leg right now. And so on this leg, I want to come down to a taper. So I'm going to go into node editing mode. And how far do I want to taper? So I want to come in here and I'm going to snap to that line with my guide here. And I'm going to right click on that guide. And I'm going to have it create a new guide relative to its position down, which is a negative number. So we're going to go negative 3/4. Okay. I'm going to close that. Now I'm going to move this guy down and snap to this corner. And I'm going to right click on it. Well, actually, I don't need it on that one. I don't need it on that one. Because, well, no, I do need it because I need to create this taper. So let's do this. Relative to its position, a positive 3/4 because we're going up. Because I'm trying to simulate the legs for you guys. So we're going to create that new guide there. All right. And so now in node editing mode, there we go. I am going to bring that leg down there, bring this end up here to create that initial taper. And now I'm going to come in and let's get out of node editing mode. And I'm going to come in and I'm going to grab the end of this and I'm going to come over and I'm going to kind of snap. Oh, right about there. Can you smell what the crock is cooking? All right. So from there, here, let's do this. Let's undo this taper first. Bring that back over. Undo, undo. Let's stay with a square profile for right now and turn the guides off. And then we'll taper from that fact. Let's turn the guides off for a moment. All right, so let's bring this profile over. And snap here. All right. Now I'm going to mirror this. Let's mirror that. I'm going to flip that horizontally, creating a mirror copy, flip it about job center, and flip it vertically, not horizontally. There. Okay. And if I were to kind of simulate the drawing of this, if I take a straight line tool and bring all my lines, my end points and eye points together. Oops. Snap to the wrong spot on that one. Let's zoom in a little closer. Oh, doggone it. Keep doing that. Okay. So, with that, let's take my trim tool. Scissor tool, and let's snip away that line. So you see what I'm cooking here. All right. Now, all right. If I were running a specialty bit on my profile, okay. If I were running a specialty bit on my profile and I wanted this profile and I had this bit, then all I have to do is draw the center line on my part where that profile cut is going to follow. And I'm going to create a profile cut on the line with that bit. And it's going to carve out that profile all the way around. So rather than having to machine with an 1/8 inch ball nose end mill, come in here and try to machine this part all the way around 360 degrees, my bit's going to come in, and it'll take steps, but my bit's going to come in and that part's going to revolve 360 degrees around. Brr, brr, you know, and be done. So my bit would come in, you know, from that square blank, and it would cut that first pass, and then it would turn another 360 degrees as it moves in for that second pass, third pass, however many passes you want it to be, and it's going to cut that profile. So now from there, let's go ahead and create our next. Let's go into node editing. And I want to create a node right about here. All right. Look about in line. If not, while we got this selected, we can grab this node right here. Shift to grab that one and hit the letter X on our keyboard and pull that into alignment. All right. Now, on this, between these two spans here, I want to change this to a Bezier curve. Or even an arc, whatever the case may be. Yeah, let's do an arc, because it's just going to be an arc anyway. So let's change that line to an arc, and we're going to pull that up to a distance of a 1/2 inch, 0.5. You see that distance blinking? And we're going to do the same thing here to an arc, and we're going to pull that to a distance of, let's zoom in a little more. All right, bear with me. Okay. Funky, chunky monkey. Okay. I want to take this profile here. And let's snap that to right about there. And mirror that. Vertically. And we're going to take this here. Might be one or the other. Might not be both. Let's see here. And let's mirror that one vertically. Okay. Now, from this point, there should be a node there, right? Is there a node there? Yep. All right. From this point to this point, with these two guys and girls selected, I want there to be a slight taper somewhere around here. All right, scissor tool, trim. Girlfriend. Aha! It's grouped. Let me ungroup. That's why we won't trim there. There we go. There we go. Let's ungroup this one. I was wondering why my scissor tool wasn't working. All right. Is this one group 2? Group 2, group 3. Ungroup. And ungroup. All right, let me get my line tool in here. Let's draw some polylines. So from this point to that point, spacebar to finish. From this point here to this. Do you have to draw the lines? No, we're just kind of creating the shape so you guys can get kind of a three-dimensional kind of view of what this part would look like in this 2D vector. Okay. All right, so all right. And so I'm not going to do the taper. I'm just going to leave it kind of like that. Now, so if I wanted to, you know, cut this table leg here and all, this shape, this, you know, this design, I can, this part here, this curvature, would really be my only modeling part that I have to do because of that curve. This section of the model, this section of the model, this section of the model would be the specialty bits. Just running a single line profile, 360 degrees around. My flats here would be the, I could get those done with the rough cut, you know, to flatten that, you know, that flat, which would be this area here that, you know, up to this line. And again, also the flat here. So the only part that I'm having to model is this part right here because of this curve, this cove, whatever it may be. So we can use those specialty bits to seriously reduce our machining time. And so let's create, let's take this bad boy here and let's move this down. And this, we're going to do this. You guys saw how we created the leg and everything a moment ago, but we're going to go through and do this here in real time. All right, so we're going to go into the node editing and node editing. And on the center line here, we're going to cut the vector. And on the center line, we're going to cut the vector. Okay. On this top half section here, all the way to that vector. Oh, I'll just shift key down. Even those lines right there. Hey, where are you going? Where are you going? Hold on a second. My mouse just decided to take the board away from me. Okay, stay there. Jeez Louise. Let's select this, and that. This profile here all the way around, making sure we're connecting them lines all the way across, all the way across. All right. Okay. So right here, we're going to group this together so I don't have to deselect all this stuff again. Did I just do that? What did I just do? I went into node editing. I deselected it anyway. All right, on this line here, we're going to cut the vector right there. And we've already cut that vector. We just need to, node editing, cut it right here. Okay. Once again, if we zoom out and we select this top half of this part, we should have that half profile right there. We do not need this line, so we're going to unselect that. No other center lines are selected. We are going to group that together as one profile. The rest of this stuff is irrelevant. Okay? The rest of this stuff is irrelevant. So we can kind of eliminate that or just move it down. You know, even this one too. Move him down. Because all we need is this top profile to create our leg, our model. Okay, so how do we draw our vectors if we're going to use the specialty bits? One, let's see if we can kind of zoom in here. Number one, we are going to use the polyline tool, and we're going to come to the center point here and wake that up so that we can come here and snap to that start point. We're going to draw that line straight across. Straight across, Laney. Straight across, Laney. 90 degrees. Okay, that's one. Number two, let's come over here and snap to the center of this one. Wait, not snap, don't click. We're just waking it up to wake up that little blue line vector right there. And we're going to come over. All right. Number three, wake that one up. Okay, we are going to put those three vectors on a new layer. We're going to put those new vectors, three vectors on a new layer. Move to a new layer, and this is going to be called our profile bit vectors. Profile bit. Yeah, that's fine. Vectors. And we're going to make them light blue. Okay. Okay. Now, we are going to create our vector boundaries. The only area that needs to be modeled with just the modeling part of this is this cove section here. The rest of this stuff is kind of flats. So let's come over and let's draw a rectangle and let's wake this up. Come over here on this corner and wake that up. So now I can, wake this guy up. resize this one because I went off my line a little bit. So if I grab this mouse here, I can come down here and I can snap back to where I need to, right there. Okay, that's where the end of my profile, my special profile bit runs. Okay, and then here with my rectangle tool, from the end of where my bit is, I don't know why I drew a rectangle there just now. Hold on a second. I'm going to just wake it up. Do not click. Wake it up. And we're going to drag that all the way across. Okay, these guys here, these rectangles, are going to represent my larger, just flat, plain clearance area. Okay, they're going to be in red. Now here, my modeling area, here, that is we're going to create that rectangle too. And so let's come over and we're going to snap to where this bit finishes right there. Wake that up. And we're going to draw a rectangle and we're going to snap to there. Get that horizontal line wake up. Let me zoom in a little bit. Bear with me a second. This one's being finicky. Finicky! Go. Alright, let's pull that all the way up on our board. And let's get this, while it's selected, let's put it on its unknown layer, move to layer, and we're going to call this our model okay. Now, let's create some toolpaths. Gonna zoom in to this area here. Now on this curvature, it is a component. Now if you guys have straight legs and all that stuff, what have you, but if you do want to create that curve, that is an aspire function because we are creating a component. We got to create a component, and we would sweep that profile along this area here. So, we would come over and go into our node editing. Dadgummit. It hates node editing for me. Node editing. That bit stops right there, so let's cut the vector. All right, I'm going to turn our modeling carving profile layer off, that rectangle there. We're going to turn that off for a minute. We're going to create a new layer and call this our model drive rails, or layer 2. Rename. Here we go. We're almost done. Model drive rails. Yeah, I'm not going to taper this leg on this. If I were, then I would just sweep those models inward a little bit, Wayne. All right. Now I could, if I wanted to taper that end, I could just bring those two from this point on. I could just bring those points down, but it didn't look right as a tapered leg from that part down. So on those model drive rails, we're going to draw our poly lines. We're going to kind of wake that up. So from here to there, bam, and over on the other side, from here, wake that up, straight up 90 degrees. All right, let's create our shape first in our modeling toolpath, our 2-rail sweep. We're going to use our 2 drive rails. There's going to be our drive rails for our selection, and we're going to grab our profile, our selection here, our profile, and we are going to sweep that between the spans and click apply. Okay, is that right? If we look at our 3D view, we'll see that profile. Nice, nice, nice. All right. Now, we're going to create our design. So let's close this and move over here. We're going to create our 3D finish cut. I'm not going to do a rough cut. There would be a rough cut that would be had, but let's kind of cut to the chase. We're going to do our 3D finish cut on this model. We're going to use the selected vectors as a boundary. Let's turn that boundary back on. Okay, that selected vector is a boundary. There we go. And we're going to use our large bit. That's just a simple cove, so we can actually do that with a 1/4 inch ball nose, 1/8 inch ball nose, 1/2 inch ball nose. But I'm going to do I should be okay with a 1/2 inch ball nose and calculate that. All right, let's preview that selected toolpath. Ooh, hold on a second there, Hoss. Don't you be cutting down that low. When you hold on. I forgot my legs. I forgot my legs coming down. So let's go into the line tool, and we're going to snap a line here. Wake up the center point. So we have that line and come straight down. And over here as well, we're going to wake. Did I snap to the right place? No. No. Let's click undo. I'm going to wake this up. Got to have those legs with your model profile, so it does, it knows the height of that model to create. So let's join that together as one vector. All right. So now that shape is one vector, and let's sweep that again. Let's delete this component. Let's turn off that model rails for a minute. Two rail sweep. Use our drive rails, our model, sweep it across between those two spans. There we go. That looks more appropriate in its height. Okay, and let's close that. Okay, now let's recalculate that 3D finish cut. Reset that preview and preview that selected toolpath. That's a little bit more appropriate. I am going to stop that And let's turn the view down to the quality down to standard so it's much faster. There we go. So we can see that cut there. Now, we have to have, yes, I can share the file, Wayne. We have to have our bits, those profile bits in our tool database, you know, if we're going to use them, right? So we need to add those 3 bits to our tool database. And so let's go ahead and do that. Okay, make sure that all my bits are not that's 1. Making sure they're not tied into anything else. Alright, that one's got to go into node editing and cut that vector right there for a moment. I should have made copies of those rather than the copies that I made being selected. Okay, in our tool database, we need to add these bits in. So we're going to go into and create a new group. This is going to be our profile bits. And in that group, we're going to create a new form bit. Now, before I do that, I only need the right half of the bit. So if I go into node editing on this, I need to first ungroup the bit, ungroup the bit. And if I can go into node editing on this, if it's going to let me go into node editing, come on now. I need to cut it right on that center point. And all I need is the right half of the bit. I'm going to join that right half together as one vector. So that way when I open up my tool database, and once again, new group, this will be my profile bits. I could actually give it the name of the bit, you know, from that list that's up above, but we're, you know, you know, this particular profile bit. And let's go with a new, oh, you booger, you son of a gun. One more time. Have your profile selected when you open up the tool database. Have the profile selected when you open the tool database. Very important. All right, new form tool. It's going to draw out that bit and put in the diameter and everything for me. My pass depth, let's a 1/4 inch is good. 20% step over, 50 and 20. It's 2 inches in diameter, so I'm going to back her down to about 40 and click apply. Okay, that's one. Let's move over. Only need the right half, so let's go into node editing mode, and right there on that center point, cut that vector there, and we should be able to select this half here. And group that together. Open up while it's selected, go into my tool database again, and under my profile category, a new form tool. A single open vector representing a light tool process must be selected. So my tool for some reason got, oh, grouping it and joining it is not the same thing. Grouping and joining is not the same thing. Let me ungroup that and let me join that those 4 vectors as 1. Okay, so they're 1. All right, I grouped instead of joined. That was my mistake. So let's come in here and in that profile bit, new form tool. It'll draw out that other half, and everything looks good there. So we're going to click apply. And bit number 3. Go into node editing mode. Let's cut it right on the center snout there. And we can select these 3 vectors and join them as 1. If we go into our tool database, new form tool. All right, this is a 3-inch diameter, bit. Got some stout to it, so I'm going to reduce that plunge rate a little. I'm not going to take a 3/8 inch plunge with this bit. I'm going to take an 1/8 inch at a time. 40 feed rate will be fine. We're going to apply and close. Now we're going to create our profile toolpath. There's going to be 3 different profile toolpaths. So we'll start with this one. All right, we're going to be cutting to a depth. All right, we're going to be cutting to a depth of, well, let's find out. Let's measure. We can actually cut to whatever depth we want because it'll just all just sink in and stuff. But let's actually get a measurement here. Our vertical measurement from this point to this point is 1.025. So that's going to be the might as well measure the other depths as well from this point to this point. 0.3906, and from this point to this point 0.6562. Okay. All right, so now that we have those depths, we can close that tool. We're going to do the first one here. We're going to select our tool, which is our form tool there. And we're going to click OK. We're going to be on the line, and we're going to calculate. No suitable vector selected because I'm an idiot. Let's go back over here and choose the selected vector. Right there. Nope, not that one. Not that one either. Right there, I said. All right, calculate. Okay, let's preview that selected tool path. We need to bring our model up a bit, or bring that down. So that start depth, see, it's too high. It's got to go down deeper, deeper, because, yep. So we need to, what is that depth? Bear with me a second while I find that depth. 1.6811. 1.6811. Calculate that. Preview that selected toolpath. There we go. All right, and then that's just going to run around 360 degrees. So our next profile toolpath is going to be, let's select our tool. And our cut depth on this guy, because he's on the back end here, 16355. 16355. Preview that selected toolpath. All right. Very nice. And I might have went a little deep with him. I'll have to look back at him. And on this one here, actually it needs to be 0.3906. 0.3906 was that one. That should be. No better. Oh, come on now. Come on, Laney. We gotta get out of here. It's 10:23. It's getting late. Alright. Preview those visible toolpaths. Done, done, and done. Come on, come on, come on. Alright, guys and girls. You probably all are still asleep now. Probably asleep. It's 10:23. We're gonna create the last two bits, and then we're gonna call it a night. Because I've got to get on a plane in 3 hours. Okay. So let's go to our 2D view for our last bit here. That's going to be 0.6562 is going to be our depth of cut. Let's go to our 2D view and grab this rail. And we're going to do a profile cut. We're going to choose our 0.6562. We're going to choose our 3-inch diameter bit on the line, calculate. Okay. All right, we are going to back this up. We're going to change the model height of this model here. We're going to back this first profile up to its appropriate depth. To its appropriate depth of 1.025. 1.025. I'm going to reset that preview, and we're going to preview those three toolpaths. Running right that straight line. There we go. And our model, our model and everything, we're going to come into our job setup on our model. And our model should be at the top of our part, not at the bottom. So we will click OK on that. All right, now on these areas here, these flat machined areas here, this vector, this vector, and this vector. We can run our that would be part of our 3D. It's not 3D really. It's really a flat profile, so we're kind of milling it around. We're not taking much off the surface, so this would be a pocket cut. Let's try that. Not a profile, pocket cut. With our large diameter end mill. I'm going to use a ball nose versus a an end mill. Don't ask me why, but I just for a smoother cut, I guess. I don't know. And we're going to take just a bit off. Okay, right here, I need to bring, since my model has this hump in here, this whole top layer needs to be brought down below this top surface. So these tools, these three things here, because that model has that hump in it. Remember, I screwed myself up by creating that hump. But let's do that. Let's. Our hump was a 1/2 inch. So from the top of the point, let's measure our highest point and our lowest point so I can see what it is. So from our lowest point here to our highest point here in the center of this, the Y distance is a 1/2 inch. So I need to bring my cuts down. I need to mill everything down a 1/2 inch. 1/2 inch. So what I'm going to do is extend this vector to there. This one I'm going to extend to here, and this one's just going to run the whole distance there. Alright, so we're going to do that pocket cut again. This time we're going to do it with a flat bit. I'm not going to pocket cut this with a ball nose end mill. Am I? Oh hell, let's do it with the ball nose. No, let's do it with a flat bit. I wanted a 1/2 inch exactly. I don't want to have to deal with that radius. And so we're going to go 0.5. And those three vectors, or two vectors, are selected. We don't need that one selected because this one's going to do the whole thing over here. And we're going to calculate that toolpath. Alright, let's preview that selected toolpath there. Let's get that milled away. Down that 1/2 inch. Don't you worry, we're milling our profiles away, but they're coming back. They're coming back. Okay, notice I got some corners and stuff left it on there because I want to extend these guys. I'm gonna hold my shift key down, extend them just a little bit. I want my bit to go past them a little. Okay, I want my bit to go past them a little bit. We're gonna recalculate that toolpath very quickly. All right, preview that selected toolpath. Have those edges. All right, now on the profile cuts, we are going to start. Our start depth is going to be 0.5 because we just milled that down 0.5 to the 1025. We're going to click calculate. Our second profile, start depth, a 1/2 inch down, 0.5. Calculate. Our third profile, start depth, is going to be 0.5. Calculate. And we are going to preview those 3 visible toolpaths. Okay. Let's wrap this up and see what we end up with. Okay. Now that let's go side by side, or top and bottom, for our view, and let's get our top view here in kind of a there we go. Let it remodel, let it regenerate. All right. And so if we, let's zoom in on this here. Let's take our leg, this lower part here, and let's bump that back up. Okay, now, how long of a toolpath is this? How long of a runtime is this to kind of create this, this specialty profile? So, the turn that off for a minute. All right. The 3D finish part of this was 1 hour and 16 minutes just to do that little all the way around. And then we're going to change that. We're going to reduce that down to 30 minutes because I forgot to change the step over. Our profile 1 was 2 minutes and 50 seconds. Profile 2, 2 minutes and 7 seconds. Profile 3, 4 minutes and 26 seconds because of the step downs. And then our pocket cut, 2 hours. Right? So what can we do to adjust the 2 hours and the 1 hour 16? Let's look at our toolpaths. One, we're doing a raster cut here. Or not a raster, but kind of an offset cut. So we're going to fix that. But let's figure out which one's doing that. Profile 1 is a straight line, so it's got to be the pocket cut. Yeah, the pocket cut. So the pocket cut, we're going to raster. We don't want to do that circle, and we want to look at. We're looking at our edit our tools. 40% is good. We can. That's a big bit. We can kind of bring this up. I'll go 0.15. I don't want to be too aggressive with my bits. 1.5 maximum. I can run that 1/2 inch end mill 55, and I can plunge it about 30. And let's we're rastering now. No profile pass. Calculate. Okay. All right. By making that adjustment, let's see what we turned that. What was it? A 5 hour or something like that. It's now 2 hours, 36 minutes. Okay, so right now with the pocket cut and the 3 profiles, we're at 2 hours and 45 minutes on this table leg. Our 3D finish cut, what can we do to adjust it? It's a 1/2 inch ball nose end mill, running at 8%. Let's bump that up to 10 or even 15. There is no plunge really. It's just milling from the bottom down, so let's bump that up to 30 and click OK. Calculate that toolpath. And now let's look at the times here and see what we did with that hour and 13. So it only took about 30 minutes off of that. But altogether, this table leg would be about 3 hours and 47 minutes. 3 hours, 47 minutes. Now, compared to if we did the whole thing as a one single model, we've saved a lot of time just by running those 2-minute profile cuts rather than that 1/8 inch bit cutting that whole model out all the way down, all the way around, up and down, all the way around. You know, those profile bits help us. So, I hope, I know this was long. It was a whole big old, hopefully some of you girls and guys stayed with me. But hopefully you understand this process. Take a look in the future at some profile bits. You know, if you're doing ornamental carvings, spindles, table legs, whatever the case may be, ornamental carvings, you know, moldings or balusters or what have you. Take a look at, you know, what's the best way I can optimize my toolpath, a specialty bit. Hey, you spend 50, 60, 70 bucks on a bit, whatever the price is, that bit is, you've got it. So, you know, one-time expense, you own that bit. Now, you know, you can use that. You can switch up these combinations in so many ways. That one bit could do so many different things. You know, when it comes to profile cuts, you can make dozens and dozens of different cool styles and stuff. If you were into making spindles and crib, you know, baby crib, you know, little banister rails, you know, on their little crib, the little spindle rails, stair rails, whatever, you know, porch rails, whatever it is that your little heart desires that you're carving. Just keep that in mind. So specialty form bits will help optimize that toolpath. I will share that file, that profile for you. I will share that file in the Facebook group, the magnate file profiles. And they're drawn out for the to scale for the magnate bits, those profile bits, those specialty profile bits. And, you know, if you see a specialty bit that you want and you don't have a profile for it, you just draw that right half of that bit to scale and you'll be good to go. I think I had a class on that somewhere about adding bits to the tool database. Leanne, I don't. Very little. Okay, ladies and gentlemen, I want to thank you for your time. I'm not going to have time for any Q&A unless you guys want to pump out some questions right now. Hit me with your best shot, and then we're gonna rock and roll out of here because I do have to jet set to the airport momentarily. And it's an hour and a half drive to the airport. I still got to pack. So, heading to Milwaukee. If you guys and girls are in the Milwaukee area, come out and see us. I don't see any questions. I think everybody fell asleep or they left. Thank you very much for the class. Hope you get some rest sometime soon. I will, Leanne. Thank you. Thank you for staying with me, Leanne, and watching this. Hopefully you picked up something. I don't know if you picked up anything, but hopefully you will... hopefully you picked up something and, you know, learned a little bit of something, kind of how to approach different drawings. Now, this approach by cordoning off, you know, vector areas and stuff. Oops, let me maximize this. This approach by cordoning off areas and, you know, using those vectors as boundaries, that applies in the flat table too when you have a model or something that you're carving. If you want to cordon off an area and use that vector as the boundary for your larger bits and then, you know, for your smaller bits, you can do that, you know. If there's special profiles or something, flutes or what have you, use your form bits, whatever the case may be. But look at optimizing your toolpaths. You really want to think about, you know, you want to get into when you're doing your modeling and stuff. Like right here, I kind of dropped the class on naming your components because I just moved over to this. But, you know, our table leg from earlier tonight's class, wrapped it up. All right, we got that high quality profile. We didn't bet that, but, you know, think about that. Your vector unwrapper tool, come back and, you know, when you're making that square peg in that round hole, Dadgummit, I didn't do my little finish cut right there. My rough cut. The rough cut would have cut that tenon away at the top, which you'll see pop up here in a minute. You won't even see it until it starts cutting that tenon, I believe. I believe I can fly. No, rough cut. Those red lines are where the router's moving around that piece, or the piece is moving, the router's not turning and stuff. But anyway, let's see here. Have a safe trip. Thank you. Thanks. This will get me thinking. All right, Alan. Yeah, definitely do so. Definitely do some thinking and everything. Check out the, when you're creating your table legs and stuff, your profiles and all. Check out about the vector unwrapper to get that square stock. Maybe one class we'll talk about how, like, if we wanted this part of the taper to be kind of octagoned, or where it's segmented, we'll talk about that, how to create that with the vector unwrapper in the future. But hopefully this helps, and I want to thank you all again. Have a great night, guys. We're gonna cut it out here, and we're gonna call it an evening, because I know you're tired of hearing me. I know you are. All right, ladies and gentlemen, thank you again for everything. Good night, guys.